Okay, 7.1, exploring exponential models. So in this lesson, we're going to talk about exponential functions. You can see these a lot when we're talking about money, investments, so savings accounts, or your auto loan or things like that. Okay, so any function written in the form y equals ab to the power of x, where x is a real number, a cannot equal 0, but b is greater than 0, and and b cannot equal 1 is commonly called exponential function. When b is greater than 1, then the function is considered to display exponential growth. However, when b is less than 1, but greater than 0, so very important there, then any function in the form y equals abx, it will display exponential decay. The value of b in each case is known as the growth or decay factor. Any line that graphs approaches as x or y increases in absolute value is known as the asymptote. Okay, so this graph right up here, this is considered exponential growth. This graph right here, this is known as exponential decay. So growth, as it sounds, growing, decay, falling, declining. So it's very important you understand that b will always be larger than 1 here. And then b will be less than 0, less than 1 and greater than 0 here. And we can also identify these two graphs. This is where y equals 2x, and this is where y equals 1/2 to the power. Oh, I wrote that. See, I'm struggling today. Here we go. Equals 2 to the power of x, and this is to the power of x here. Okay, so let's practice so we can get an idea of how we're going to do this. So here we have, it says graph y equals 2x. So it's very important you make a table. Anytime you're talking about graphing, you want to make a table. So you just take this -2 you see here, and we want to plug it in. So we have 2 to the power of -2. That's what you type in on your calculator, and it should give you 1/4. Here, it would be 2 to the power of -1. So your calculator is going to tell you it's going to be 1/2. Anything to the power of 0 is 1. Yeah. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And then 2 to the power of 3 is 8. So 2, -1, 2, 0, 2, 1, 2, 2. And how we get these 2's is by this equation right here. And hopefully you're aware how to graph. We're looking at, you're graphing your x and your y. Okay, so I'm going to change up my points here. I'm at -2, 1/4, so this is going to be very, very little. -2, 1/4. -1. Oh, I put that on the wrong side. Oh, I hope you were telling me, hey, that's not right. So x is net. Yes, it was. I was too. Oh my goodness. 2 to 1/4. -1 to 1/2. 0 to 1. 1 to 2. 2 to 4. And 3 to 8. There we go. Hopefully you're able to tell what type of graph it is. This is an exponential growth. how we know that is this number right here is larger than 1. Okay. So let's talk about like the characteristics of your exponents. So your domain is going to be negative infinity to positive infinity, all real. Fill that in. All real numbers. Okay. Your range is from 0 to infinity. Y has to be greater than 0. All positive real numbers. Your asymptotes, y equals 0, and the x-axis. Key points here are 0 and 1, your y-intercept, and then there are no x-intercepts. Okay, pause that if you need help. So let's look at some quick examples. We have to identify, is it growth or decay? Explain how we know. So looking here, we have 3 and then 4 to the power of x. So this is the number we're looking at, and this is growth because it's larger than 1. Your base is 4. We know b is greater than 1, as I said, and your y-intercept right here is 0, 3. Okay, let's look at b. Right here is how we decide, is it going to be growth or decay? Hopefully you're saying decay because it's less than 1. So we know our base is 0.75 or 3/4. And then our y-intercept, we're looking at this number right here. So our y-intercept is going to be 0, 11. Here's a word problem. It says you save $2,000 in a college savings account for 4 years. The account pays 6% interest. So if you're saving money, do you think you're going to be growing it or you're going to have a decay? You're losing it. Hopefully you're saying growing. So this is growth. Your base is the investment. So it's the investment plus the 6% that you're seeing. So that means it's b equals 1.06. If you don't know how to turn this into a percentage or into a decimal, go look it up, but it's 0.06. And your y-intercept is going to be 0 to 2,000. Why it's 2,000 is because that's what you start with. Okay, so let's talk about modeling. This formula right here is going to be your friend. So write it down, save it, whatever you need to do. The A in this formula means it's the initial amount. Okay. R here is the number of time periods. This little a right here is the amount. I'm going to come right here. Amount after t time period. So amount. We'll put this in an example where you can see. And then this t right here is the rate of growth or decay. Where r would either be greater than 0, that's a 0, and less than 0. Okay. Okay, so let's put this into an example form here. Suppose you invest $500 in a savings account that pays 3.5 annual interest. How much will be in the account after 5 years? So hopefully you're telling yourself we have growth. So you should see a problem where it's growing. And the formula we want to use is what was given above. A 1 plus r to the power of t. Okay, so let's plug in what we know. Your investment, so this is $500 starting out. That's going to be the little a that we have. This right here is our r, so we want to turn that into a decimal. So it's going to be 1, then it's going to be plus 0.035, and then t in time, so we're looking at in 5 years. And you can type this all in on your calculator if you want to get your answer. Make sure you put your parentheses in there. And you're looking at approximately $593.84. After 5 years, that's what you're going to have. So if you wanted to dig it a little bit further, that means you earned $93 in 5 years, $93.84. Okay, here, real quickly, because I'm only allowed to record for 15 minutes, it says you're investing $500 in a savings account, blah, blah, blah. When will the account contain at least $1,500? So the roles here changed a little bit. Same formula that we have up here, but instead we're saying 1,500 equals 501 plus 0.035 to the power of t. And that's what we want to look for. We have to find what t is. Okay. You could graph this if you wanted to. Order of operations says, okay, we want to divide by 500. Okay. And then once we do that, we get 300. Or 3, not, why did I say 3? So 3 equals 1 plus 0.035 to the power of t. I think this lesson's wanting you to graph it. So I may be messing up here. And it does, because we're going to talk about how to solve this in a later lesson. So scratch what I just said right there and graph your equation, which is right up here. Okay, type this into a graphing calculator and then look at your y value. When it's at 1,500, you're going to give an estimate time, and it's approximately at 31, 32 years. So graph, that's what I'm going to put down here, graph it. Okay. This is the last problem. I got to make this quick because I got 2 minutes. So this is another word problem here. They give it to you in terms of your model here. So read your problems, and I'm going to fill this in really quickly. So y equals 150.8x, y equals 150.8 to the power of 11. Solving that, y is going to be approximately 13. We're looking at the years since 2003. That's going to be very important to you. Okay, so from 2003 to 2014. What's the difference in between those years? Hopefully you're telling yourself 11. Okay. X is the years since 2003. Y is the population of your Bobcat or the Lynx. Down here, they're asking you to solve for R. So you would do 120 minus 150 all over 150. Get that answer. And then this one's going to be 1 plus negative 0.2. So this B is going to equal 0.8, and this r is going to equal 0.02. Okay, I'm out of time. It's fixing to turn out on me. But if you have any questions on this lesson, feel free to send me an email.